Hello and welcome back to AP Psychology. I'm Miss Lee. Today's video is our first video in the series for sensation and perception. We are focusing today on an introduction to sensation and some of the influences about how we sense certain things. We have a lot of learning targets, so I want you to go ahead and pause here if you would like and look over to make sure that you are familiar with what we will be covering, so that you know that we're on track. If you haven't done so already, go ahead and grab your notes and let's get started. Okay, so a lot of you probably know what this image is, and I want to ask you, how does this image get into your mind? Do you chisel your skull, insert the photo, and close it back up? Of course not. So how does it get into your mind? And at what point do you recognize who the image is of? Think of the process with the image. When we're talking about sensation versus perception, it's the process of constructing mental representations of the external world. But to be able to represent the world, we have to be able to detect physical energy, a stimulus, information coming from the outside, and converting it into neural signals that our brain can use to be able to figure it out. This is a process called sensation. When we select, organize, and interpret our sensations, when we try to figure out what those sensations mean, it's called perception. So I want you to just jot this down in your notes. What do you sense? In this case, what do you see? We're going to come back to this in just a few moments. So there are a couple of ways of processing the information. The first one is bottom-up processing. This is how we analyze the stimulus, beginning with the sense receptors. So the information actually landing inside the sensory receptors. They're in different parts of your body, and then those sensory receptors send the message to the level of the brain and the mind. So this is stimulus coming in. Which of these is the American flag? You know which one it is because of bottom-up processing. The information is going into our eyes, and we are able to tell because of the different lines and the colors that we are interpreting that it is the American flag in the middle. Top-down processing is using information guided by high-level mental processes, and we are constructing those perceptions drawing on our experiences and our expectations. So what we have already experienced, what we know of language, and what we're expecting of language. That's how you can read what is written on this slide, even though every other letter is missing. See what I did there? So I told you we'd come back to the polar bear. So this was a cookie that Starbucks sold a couple of years ago around the holiday season. And many of us have been exposed to things like red scarves. However, a lot of us have also been exposed to some very violent, graphic movies and games. And so some people interpreted the polar bear in a very different way, even though Starbucks claims that they were making the polar bear with a red scarf. Other people actually perceived the polar bear as having its throat cut. Our expectations, our experiences, if you have grown up in a very hot environment, maybe you've never had any experience with a scarf, but you watch violent movies all the time, that could potentially influence what you are interpreting the polar bear to be. By the way, Starbucks had to take the polar bears off the shelves very quickly. Okay, let's talk about thresholds. There's this concept called an absolute threshold. This is the smallest amount of stimulation needed to detect a particular stimulus half of the time. So the smallest indicator that there is a stimulus. The difference threshold is the minimum difference between two stimuli required for detection half the time, also called the just noticeable difference. All right, so let's get into this a little bit. Okay, so let's get into this just a little bit. An absolute threshold. Have you ever been in a hearing test where they've got the earmuffs on you and you're waiting to detect the beeps, and you hear a very low beep and you raise your hand and you think maybe you heard a beep, but you're not sure, so maybe you raise your hand or you don't. That absolute threshold, that is the point at which you start hearing that stimulus, that beeping. And believe it or not, the beeping has probably been happening before you actually detect the beeping, because there is an absolute threshold that is different in every person. So I may hear things differently from you because my absolute threshold is different. Difference threshold. This is sort of like, how much do you have to turn the radio up in order to be able to detect that somebody has turned it up? If you are in the back seat and you're like, hey, could you turn the radio up? And somebody just turns it up just a little bit. Well, they've turned it up, but can you detect a difference? At what point do you hear the difference? And kind of piggybacking off of that is Weber's law. Basically, Weber's law is stating that the size of the just noticeable difference is proportional to the intensity of the stimulus. So if the stimulus is very high, if the radio is very high, that sound is really loud, the just noticeable difference will be large. It's going to take raising the volume up by a larger percent in order for you to detect the difference. If the radio is relatively low, the just noticeable difference will be smaller. So it's not going to take as much for you to be able to tell the difference because of the proportionality of it. Subliminal threshold. This is when stimuli are below one's absolute threshold for conscious awareness, although you may actually have some stimuli coming into your subconscious awareness. In other words, for most people, the items aren't consciously detected. However, it's possible that some will notice these items. Studies have found that subliminal words flash briefly on a screen can sort of prime someone, get them ready for a person's later response. So they may not even know why they're responding a certain way later on, but it could be a subliminal message sent along the way. So even though it may prime a person's later responses, it doesn't really impact a large group's buying habits. And if you kind of recognize the terminology here, buying habits, a lot of the research in this area has been conducted by organizational psychologists. The next idea is signal detection theory. Simply put, it states that our thresholds are not absolute, they change. And signal detection theory is going to predict how and when we are able to detect the presence of a faint stimulus or signal, even though there may be some background noise or other stimulation happening. And the theory assumes that there is no single absolute threshold and that our ability to detect a stimulus depends on experience, again, expectations, motivation, and levels of fatigue. So you see a little chart here, and basically signal detection theory has a couple of different quadrants. You've got either the presence of a stimulus, yes or no, and detection of a stimulus, yes or no. We're going to be doing an activity in class that kind of underscores this process, but basically signal detection theory, you are either going to get a hit or a miss, and we will have an activity in class that goes over this a little bit more concretely. I just want to expose you to the signal detection theory very briefly. Sensory adaptation. So you've got adaptation that goes kind of two different ways. You've got diminished sensitivity as a consequence of constant stimulation. You see the monkey with a little Band-Aid on its forehead. When you first put a Band-Aid on, you're very aware of the Band-Aid, but over time, you gradually become less aware that the Band-Aid is there. It hasn't changed. What has changed is you are less able to detect it because of the constant stimulation that the Band-Aid is providing. Other examples would be like wearing glasses, wearing jewelry, or getting into a cold pool. All of these are different ways that our bodies just sort of adapt to an environment that doesn't change. It's not that the pool is getting warmer, it's that you're getting used to it. So how do we organize objects when we perceive? Okay, so this may be a term that if you have any experience with art, you may have heard about before, gestalt. Gestalt psychology helps us to organize information into meaningful wholes. Our brains do not like random pieces, and our brains really like patterns. So you have to remember that the whole is different than the sum of its parts. One of the ways that we organize items in a gestalt manner is through the figure ground. So in this image, you see a couple of different things here. This is an organization of the visual field where objects stand out from their surroundings. So even though there isn't really a star there, we do see a star, don't we? It's actually made from the absence of knees, if you look at the picture, we do see a star because it stands out from the background. Some examples of gestalt grouping. So this is how our brains organize figures into meaningful forms using some very consistent types of rules. So we're going to start kind of at the top, and you see similarity. So even though one could argue that these are just a bunch of dots, don't we also see lines of white and black because those lines have similar items grouped together in that way? So if we continue down towards continuation, we're going to the right kind of clockwise. And even though you could argue that these are separate pieces, it looks like there is one key kind of overlapping another key. Because of what we expect the figures to be doing, we think of them as both having continuous lines, even though we don't see them. So we assume that the bottom key has a continuation, even though really and truly the way it's drawn, you could argue it either way. It could be two broken parts. If we keep continuing around, there's connectedness. This is not just two circles and a line. We assume that they are connected. We assume that this is one whole item because of the way that our brain kind of groups items. The next grouping is proximity. Instead of just seeing a bunch of dots like we see kind of in the left figure, in the right figure, because of the way they have been arranged, we see 3 columns in addition to the fact that it is just a bunch of dots. We don't really see the dots anymore as much as the 3 columns. That's what kind of stands out. And that's because of the way they have been grouped closer together. And then that last grouping at the farmost left corner is closure. We don't just see kind of random lines. We actually see figures, don't we? We see a circle. We see, I think technically that's a rectangle, but it looks like a square. But we see figures, even though there's nothing connecting them. We assume the closure. Our brains fill in the gaps. Okay, depth perception. This is something that enables us to judge distance. And research back in the 1960s suggested that human infants develop this depth perception while they are crawling in order to have some protection. So even newborn animals will show depth perception. What you see in the picture is a very famous experiment where certain age babies were not able to detect a visual cliff. That's what this is called. So even though we know that there's safety there, we know that there's a hard surface, it's glass, the babies don't understand that, and it looks like there's a drop off. Some babies at a certain developmental age don't perceive that depth perception yet. And you can kind of tell when they do start seeing it because they won't crawl over it, even if their caregiver is on the other side, like it's being depicted in the picture. Okay, so how does all of this come together? Well, one of the most important sensory receptors is our eyes. And we have a couple of different cues that give us some sense of how we are supposed to perceive things. The first kind of category is monocular cues. This is the way that the eye will, again, kind of fill in the blank. Our brains don't like unanswered questions. And so this first one is interposition. If you look at the picture, objects that occlude or block other objects, we tend to perceive them as closer. So you perceive the blue person in front because it blocks part of the red person. Even though we don't really know that that is true, that's the way that we perceive it because that's what our experience tells us. Another type of monocular cue is a linear perspective. So think about when you are looking at a road or a railroad. It looks like the lines appear to converge in the distance, even though they don't. The more the lines converge, the greater their perceived distance. So if they come to that narrow point fairly quickly, it looks like that point is far away. The more the lines converge, the greater their perceived distance. Another monocular cue is relative size. So if two objects are similar in size, we perceive one that casts a smaller retinal image as farther away. So these two items are similar in size, but because one is slightly smaller, it casts a smaller retinal image. The one on the right we perceive as being slightly farther away. Another monocular cue is texture gradient. As texture becomes more fine or indistinct, we perceive an increasing distance. So if you look at the picture on your slide, it looks like as we get kind of closer to the building, it gets further away. Even though we don't know that to be true, all of the signs are kind of leading to that. You've got texture gradient, individuals are smaller and they get smaller and smaller as they appear to get further away. So you perceive the paver tiles that are smaller and less distinct in texture as farther away because there is more texture closer to you. Okay, binocular cues. These are cues that you kind of have to have both eyes working in order to be able to see them. So the first one is convergence. When two eyes move inward or towards the nose to see near objects and outward away from the nose to see far away objects, the object is perceived as closer the more the eyes turn inward. And if you look at the picture, you can see that there is a difference in distance from one eye to the other. So that is going to give you some clues as to where the item is in space. And the last type of binocular cue is retinal disparity. Basically, images from the two eyes are different. The greater the difference between the two objects, the closer the object. So what I want you to try to do is replicate what is happening in the picture. Try looking at your two fingers half an inch apart, about 5 inches away. You will start to see a finger sausage, just like in the inset. If you can't quite get there, we will try it again in class as well as some other demonstrations. Our next video will be an introduction to perception. I can't wait to see you then. Bye for now.